So let's look into a little bit more carefully the scale invariant features that we're interested in. The Harris Laplacian is one type of a scale invariant feature. Basically, it finds local maximum of Harris corner detection in space and Laplacian in scale. What that basically means is I have x and y with either translations or transformations, scale. In essence, if I have something in space here, this feature could also be measured in different scales. Laplacians, again, remember all of our work on Laplacian pyramids and Gaussian pyramids that suggests how we could do this kind of stuff. So in essence, we can actually find the feature in different scales, which means that now the same feature, if you zoom into an image, the feature got bigger, we should be able to detect it with this approach. So in essence, the Harris space is here and the Laplacian is in scale. So Harris is x and y and Laplacian is in scale. Another scale invariant detector is SIFT, and we'll cover this again in a lot more detail, but I just wanted to introduce this very briefly here. It attempts to find local maximum of difference of Gaussians in space and scale, and then difference of Gaussian is simply a pyramid of differences of Gaussian within each octave. So this accounts for variety of different things that are in the frequency domain, and again, we're looking for these difference of Gaussians in both space and scale. Again, looking at our simple example or simple schematic here, looking at variations in space. But when we go up in scale, we can actually start looking for information with difference of Gaussians, both in x and y, and also difference in Gaussians in scale. Again, we'll cover this a little bit more in detail at a later lecture. So SIFT, in essence, refers to a scale invariant feature transform. It allows us to look for changes in orientation and basically allows us to find features within it. So it allows us to compute the best orientation for each key point region in an image, and also captures key point description, where we basically use local image gradients at selected scale and also look for rotation to describe each key point region.